Hello! Today we'll talk about a special type of double linked list.
Wow, that sounds great. I always wanted to learn more about linked list. Please tell me about it more.
Sure. Today we'll have a special type of double linked list, such that it has 3 pointers. A pointer pointing to the next element, a pointer pointing to the previous element, and a pointer pointing to a child element. Imagine we have a list such that any elements in the list can contain a child list. And any of that list can in turn contain more child lists. Can you write a function that takes the head of the list as a parameter and returns a list with all the elements in the list flattened? Take some time to think about it. Pause the video if needed.
Before going through the approach, just a reminder, please don't forget to subscribe to our channel. That'd be really helpful, so that we'll be able to post more coding problems. Let me see. Should I modify the list in place or should I return a new list with the input list unmodified?
Good question. You can assume that there is no restriction and you can modify the input list.
Alright, got it. Here is one approach that I can think of. First, we loop through the elements in the list and find the element that has a child. Then, we modify the list so that the next pointer points to the child. And we connect the child list to the element that is broken from the list. The modified list would become this. Then, we repeat the process for the next element in the list that has a child. And we continue the process until we reach the end of the list. The final list should have all the child lists flattened. That's it. That's my basic idea on how to modify the list so that all child lists are flattened.
Very good. Let's see how we can turn your idea into code.
Sure, definitely. First, we define a function called modifyList. It takes a node pointer as a parameter, and it returns a node pointer to the modified list. We do a parameter check, and simply return null if the parameter is null. We then loop through the list to find the element that has a child. When an element with a child is found, we save the next pointer so that we don't lose track of the next element. We then modify the next pointer to point to the child. We also update the child's previous pointer and set the child pointer to null. Next, we connect the last element of the list to the element that we saved earlier. The for loop would repeat the whole process till we reach the end of the list. When the for loop is finished, we simply return a pointer to the head of the list.
Great job, that's a good solution, and the algorithm is easy to understand. That's for today. Thank you for watching. See you guys in the next video.